you can perform different operations on functions like addition, subtraction, multiplication, and division. The way that they are written, there's two different ways that you can see them, and that's illustrated by the box. So you can have f plus g of x, which is the same thing as f of x plus g of x. So when you see f plus g of x, it just means take f and g together and add them. So you're not multiplying any additional x's to anything. These are just talking about the functions in general. So same thing goes for subtraction, multiplication, and division. So for these examples, we want to find the resulting function and then state the domain. So for number 1, if I have f minus k of x, it doesn't mean subtract f and k and then times it by x. The other way to write this, if you like the other way better, would just be f of x minus k of x. So we're just taking the f function and we're subtracting the k function. So I'm going to take the 5x squared minus 8x, and I'm subtracting the k, which is 12 minus 3x. So all we're doing is just distributing the negative, and then we're going to combine any like terms that we have. So this becomes 5x squared minus 8x. We're going to distribute the negative to get negative 12 plus 3x. And then we're going to combine like terms. So 5x squared minus 5x minus 12. Okay, and then we also have to find the domain. So this is a quadratic, so the domain would be all real numbers. Okay, so we want to have both as part of our answer. For number 2, we're multiplying k and g together. So again, if you would rather see this written as k of x times g of x, if that makes more sense to you, you can rewrite it. So we're taking the k function, which is 12 minus 3x, and we're multiplying that to the g function, which is 4 over 5x. So we're multiplying a fraction times a number. If you feel more comfortable to make this 12 minus 3x over 1, so you have another fraction, you're just going to multiply straight across the top. So 4 times 12 minus 3x. I'm going to distribute the 4, so I have 48 minus 12x. And on the bottom, 1 times 5x is just 5x. Okay, so when we find the domain, we want to find the domain of the resulting function. So the boxed function is a rational. So we look at the denominator and we say it's all real numbers except what makes that denominator 0. So in this case, it would be domain is all real numbers except x cannot equal 0. Okay, and then in the third one, we're dividing g and h. So again, if you want to rewrite this, it would be g of x over h of x. So we're just taking the g function, which is 4 over 5x, and we're dividing it by the h function, which is radical 7x. So we can change this to multiplication because we're dividing by radical 7x, which is the same thing as multiplying by 1 over radical 7x. Okay, so if we multiply this across, we get 4 over 5x radical 7x. And remember, you can't have radicals in the denominator of a fraction, so we have to rationalize this. So we're going to multiply by radical 7x over radical 7x. So now on the top, we have 4 radical 7x. And on the bottom, the 7x, radical 7x and radical 7x become 7x. So I have 5x times 7x. And I get 35x squared. And then for our domain here, so typically, overall, this is a rational function, right? So we would say that it would be all real numbers except x can't be equal to 0. However, we have a radical involved as well. We have radical 7x on the top. So we know that we can't have any values that's going to make the radical negative. So if we find the domain of radical 7x, we know that x would have to be greater than or equal to 0. Because x can be 0, because 0 times 7 will be 0, but nothing less than 0. And because it's a rational as well, and we know that x can't equal 0 because it's x squared in the denominator, we would say that our domain is just going to be x is greater than 0. So So you're kind of looking at two different types of functions in one. If you have a radical, the radical takes precedence because you can't have negatives underneath your radical. So you want to focus on the radical and then use the rational to kind of tweak it a little bit. So normally, it would be x is greater than or equal to 0 if the denominator was not there. But because we have that denominator, it cannot equal 0. So we just take away the equal to sign. Okay, so if we look at these, I'm just going to kind of go through these a little bit quickly. So f times k of x, we're just going to multiply f and k together. So 5x squared minus 8x, and we're going to multiply that to the k. So that's 12 minus 3x. And then we're just going to FOIL this. So I get 60x squared minus 15x cubed minus 96x plus 24x squared. And I'm just going to combine my like terms. So I'm going to put this in standard form just because you don't have to, but we want to combine our like terms. So 60 and 24 is going to give us 84 x squared minus 96x. Okay, and then this is a cubic function, so our domain is going to be all real numbers. Number 2, we're doing k divided by h. So we're going to take the k function, which is 12 minus 3x, and we're going to divide the h function, which is radical 7x. So we can't have a radical in the bottom, so we're going to rationalize this by multiplying by the square root of 7x on the top and the bottom. And we're going to distribute that square root of 7x, so it's going to be 12 radical 7x minus 3x radical 7x, all over 7x. So this is similar to the problem that we did before, because we have a rational overall, but we have a radical on the top. So the radical takes precedence. So in that case, if we set 7x to be greater than or equal to 0, we would get x is greater than or equal to 0. But because we have a rational, we can't have x equal 0. So our domain is going to be x is greater than 0. And this was our answer. Okay, and then the last one, f plus k. So we're going to take the f function, so 5x squared minus 8x. We're going to add the k function, which is 12 minus 3x. So we can combine our like terms here, so 5x squared, and then we have a negative 8x and a negative 3x, so a negative 11x plus 12. And this is a quadratic, so our domain is going to be all real numbers.